So hi guys, I am here to discuss prelim. So in week 1, materials used for shipbuilding. The materials issues relating to construction of ship. Strength, buildability, toughness, marine corrosion, formability, the cost. So common methods and weld defects in ships industry. The three main welding techniques that is used in shipyard are as follows. 1. Arc welding. 2. Gas welding. 3. Resistance welding. In week 2. Bulkheads. Function of bulkheads. So, subdivision. Contain flooding in event of damage. Transverse strength members. Protection against rock stresses. Effective barrier against the spread of fire. Resisting any tendency of deformation of ship. In week 3. Survey and dry docking. Standard interval of 1 year harmonized survey for ships which could be based on any of the following. 1. Initial survey. 2. Periodical survey. 3. Renewal survey. 4. Intermediate survey. 5. Annual survey and additional survey. So in week 4, I understand about Simpson's rule 1 to 3. In 1, uses formula 1 for 1. In 2, uses formula 131. In 3, uses formula 141 and 1331. For midterm, I've learned effects of density, free surface effects, and also in week 2, stability at large heel angles, and in week 3, I've learned least trim uses hydrostatic data, and lastly, week 4, I've learned draft survey include LBP and CB relative to the ship's waterline or actual loaded condition, lightweight, density of the water in which the vessel is floating, draft readings port and starboard at the stern, midship and to the bow, distance from the aft perp to aft draft marks, distance from amidship to midship draft marks, distance from forward perp to forward draft marks, distance of LCF amidship, cargo weight or constant, for example, says 10,766 tons. So in semi-final week 1, wind heeling moment ice aggregation icing allowance, minimum wind heeling criteria that applies to all ships in specified in chapter 3 of the Code of Intact Stability for all ships covered by IMO instrument. Alternative requirements applicable to container ships are specified in MCA publication load lines. Instruction for the guidance of surveyor are similar to those specified in the IMO code. So on week 2, rolling period, still water rolling. 1. Restricted rolling in still water. Unrestricted rolling is hypothetical condition that assumes that the ship's rolling is frictionless fluid that the amplitude of oscillation remains constant. 2. Restricted rolling in still water. When ship is rolling in still water, it will resistance caused by friction between the hull and the water. The water itself will be set in motion. This will also resist the rolling. In week 3, inclining experiment. Ship stress calculation. When a ship is floating in the still water condition, the hull experiences longitudinal deflection created by the uneven distribution of weight force and buoyancy forces along its strand. So in week 4, dry docking. It is required that all ship is dry docked for inspection and maintenance below the waterline. So dry docking and grounding. When a ship entered the dry dock, she must have positive initial GM, be upright and trimmed slightly, usually by stern. On entering the dry dock, the ship is lined with her centerline vertically and centerline in the keel. Blocks and the ship shore are placed loosely in position. IMO intact stability criteria and IMO recommendation. On final week 1, importance of maintaining stability during loading. Ship stability is an area of naval architecture and ship's design that deals with how a ship behaves to sea, both in still with water and in waves, whether intact or damaged. Week 2. Importance of maintaining stability during transit in various conditions. A ship with proper weight distribution provides better protection at sea. However, when a ship is empty with no cargo, they are most unsafe to extreme condition. To improve stability during such condition, filling of ballast tank is considered best. So damage stability caused by 1. Three kinds of collision: high, moderate energy or low energy. 2. Grounding or standing. 3. Flooding due to firefighting operation, internal damage and hull plating failure. 4. Cargo shifting. 5. Ice accumulation. So in week 3, I've learned damage stability of ship. In week 4, lastly, objective of the damage control. The three basic objectives of the damage control are: 1. Prevention. 2. Minimization. 3. Restoration. 4. Principle of investigation that should be considered in investigation of damage. 1. An investigation must be thorough. 2. It must be conducted with caution. Results of reported clearly and quickly. Lastly, investigation must be repeated. And that's it. Thank you.